Session 5.2 Complement and Addition Rules. First, we're going to talk about the complement. The complement of an event E is the event that consists of all the outcomes not in E. For example, if there is a 60% chance of win today, then there is 40% chance that it will not win. So win and not win are the complements. So something happen and will not happen, they are the complement. And complement of the E, the notation is going to be E bar here, or some of the both will be using the E and then put the C on the right hand corner. Okay, both of them are same thing. This is called the complement of E. And we have the formula that P of E plus the P of complement of E will be equal to 1. And it makes sense, right? Either win or not win. So 60% win and 40% it will not win. When you add it up, it has to be 100%. Okay? So when you add up the complement E and the not E has to be equal to 1. And we could play around the formula. We could subtract like P of E for both sides. So this is going to be the new formula here. And in words, probability of the complement of E is equal to 1 minus the probability of E. Okay, look at the example. Using the complement rule to find probabilities. Consider the experiment of randomly select a student in a pre-statistic class. The probability of selecting a student with blue eyes is 0.3. Find the probability of selecting a student who does not have blue eyes. So first, we're gonna let B be a student with the blue eyes. So the complement of B means a person or a student does not have a blue eyes. Okay, does not have a blue eyes. And then we're gonna use the complement formula. Okay, this is what we're looking for. We're working for finding a student who does not have a blue eyes. So we're gonna 1 minus what is the probability of B? Probability of a student with the blue eyes is gonna be 0.3, right? So plug it in. You could get 0.7. So probability of selecting a student who does not have a blue eyes is going to be 0.7. So we say with the blue eyes, does not with the blue eyes, this is going to be the complement. When they add it up, has to be equal to 1. Okay, mutually exclusive events. Two events are said to be mutually exclusive. We call this disjoint if it is impossible for both events to occur. For example, when I flip the coins, it is impossible to get a head and a tail at the same time. Alright, if I only flip the coin once, I only can get either head or tail. It is impossible to get head and tail at the same time. So we say getting head and tail, this is a mutually exclusive event. Okay, they can't happen at the same times. And I got to use the picture to represent it. So this is a probability to getting the head, and this is a probability to get the tails. You could see that's a disjoint. Means they can't happen at the same time. And for the addition rule for the disjoint events, if I want to find probability A or B, you could see the union here. This is means like or, okay, or A or B. Probability to get A or B, you could just add it up for both of them. Add up these two probability. And then we have not mutually exclusive event. Okay, not mutually exclusive means both events can occur at the same time. For example, It is possible that I'm eating my breakfast while I'm reading a book. Okay, so think about it. This is the probability that I'm eating my breakfast. Okay, you could see I have the intersections in here. Okay, intersections here in the middle. This is talking about A and B. In this part, this is talking about the probability that I'm eating my breakfast while I'm reading a book. Okay, I'm gonna do these two events at the same time. And this part here, outside here, this is the probability that I'm only eating my breakfast. Okay, and this part, that will be the probability that I'm reading the book. So the intersection means they can happen at the same times. I'm eating my breakfast and I'm reading the book at the same times here. So in order to apply the addition rule, if I want to find A or B, okay, probability A or probability B, we're gonna add up here, probability A plus probability of B. But you're gonna see if I add up here, I'm gonna duplicate the intersection. I add up this part like twice. So that's why I need to take out one of them. That'll be minus P, A, and B. Okay, take out one of them. So when they are looking for the probability, say or A or B, you have to think about it first. Is these two events are mutually exclusive or not mutually exclusive? Mutually exclusive means they can't happen at the same time. So if this is a mutually exclusive, finding the probability, just add it up. If the event is not mutually exclusive, means they can happen at the same time, when you're finding the probability A or B, you need to subtract the intersection, the probability A and B here. Using the addition rule for disjoint events. Example 1. A 6-sided die is rolled once. Use E to stand for an even number outcome and F to stand for the outcome 5. Find the given probabilities. So we're gonna roll the 6-sided die. First, write down the sample space. Remember what is the meaning of a sample space? What number you can get, okay, when you roll the die once. So since this is a 6-sided dice, I should be getting 1 or 2 or 3 or 4 or 5 or 6. And we want to find the probability of E, okay, probability of even number. So we're gonna use the basic probability formula, favorable E over the total outcome. So look at the sample space. Which one is gonna be your even number? I will have a 2, 4, and 6, right? These three numbers will be the even number. So favorable E, that'll be 1, 2, 3. We have 3 even number here out of the 6 total outcome. And that will be 0.5. Okay, number 2, probability of F, and F stand for the outcomes 5, right? So again, we will have the same sample space, 1, 2, 3, 4, 5, 6. And then the outcome 5, which is gonna be here. So we're gonna use the same formula, favorable E over the total outcome. So favorable F, this is gonna be 5, right? So I only have a 1, 5 out of 6 outcome. Okay, number 3, probability E or F. Okay, when you see or, first think about it, if these two events are mutually exclusive or not mutually exclusive. Okay, so E and F, is it mutually exclusive or not mutually exclusive? Can they happen at the same time? So let me use a diagram to represent it. So E means the even number, so 2, 4, and 6. And then the F is going to be talking about the outcome 5, right? I don't have a 5 here. So you can see this picture. This is going to be disjoint. So this is mutually exclusive event. They can't happen at the same time. So when we apply for the addition rule, I just need to add up these two probabilities. What is a P of E? We have a 3/6. What's a P of F? That's a 1/6. All right, add it up. So you should get 0.667. Okay, example 2. A 6-sided die is rolled once. Find the probability of rolling a number that is at least 3 or is even. Okay, first, write down the sample space. Again, we're gonna get 1, 2, 3, 4, 5, and 6. And then we want to find the probability that is at least 3, okay? So we're gonna let t is at least 3. At least 3 means x is gonna be greater than or equal to 3. Okay, so think about it. What's x greater than or equal to 3? In this sample space, 3 is greater than or equal to 3. 4 is greater than or equal to 3. 5 and 6 is also greater than or equal to 3. So means I want to get 3, 4, 5, or 6 in here. And what is an even number? Okay, we're gonna let E, the event E is even number, which is gonna be 2, 4, and 6. Again, we want to find probability that at least 3 or is even, okay? When you see or, you need to think about it if these two events are mutually exclusive or not mutually exclusive. So compare the outcome for these two. You could see we have a 2, 4 here, we have the 6 in here. So means T and E, they can happen at the same time. If I use the diagram, that will be 3, 4, 5, 6. Okay, I put like 3 and 5 outside on the intersections. And an even number here, that'll be 2 is outside here. So means like 4 and 6, they are duplicate, right? And 3 and 5 is outside here, 2 and is here. So you know this is not mutually exclusive, okay? Not mutually exclusive. We'll be using the addition rule for this guy. Okay, so we're gonna use the addition rule formula. So figure out one by one, what is a probability to get at least 3? So look at here, probability to get at least 3. We have 4 outcome out of 6. What is the probability of E to get the even number? We have a 3 outcome out of 6. Okay, what is the intersection T and E? So we're going to be look at in the middle here. We have a 2 numbers out of 6 outcome. So we're going to subtract T and E here. So do the math here. 7 minus 2, which is going to be 5/6. And that will be 0.833. Finding probabilities that involve non-disjoint events. A total of 1,287 randomly selected adults were asked the following question: do you agree or disagree? Gay couples should have the right to marry one another. Their response and their religious preference are summarized as below. So we could have the table here. We have a total number of the people who agree, neither agree, non-disagree, or disagree. And then they have a different religious. An adult is randomly selected from those surveyed. Use D to stand for an adult who disagree. Okay, D represent the disagree here. And C to stand for Catholic. find the given probability. So first, we want to find the probability of D, okay, who disagree. So we're gonna use the basic probability formula. Favorable D over the total outcome. So you're gonna look at it. How many total of them disagree? Okay, disagree, total. It's gonna be 507 over the total outcome, which is gonna be 1,287. Use the calculator. You should get 0.394. Okay, number 2, find the probability of Z. How many people who are Catholic? So look at the total, it should be 301, right? So again, use the same formula. So favorable C will be 301 over the total outcome. Use the calculator. That will be 0.234. Okay, number 3. Probability D and C. Remember this notation? This is called N. So we want to find probability D and C. So who disagree? Disagree and Catholic. So you could see disagree here. Catholic is gonna be here. So N, okay, disagree and Catholic, that'll be 94. So again, use the same formula, favorable D and C, which is gonna be 94 out of the total outcome. You should get 0.073. Okay, number 4, D or C, okay? This means like or, D or C. Remember I say every time when we're looking for the probability using or, you need to think about the addition rule. So first, you need to know if these two events are mutually exclusive or not mutually exclusive. Remember, mutually exclusive means they can't happen at the same time. Okay, they can't happen at the same time. So what we're gonna do, if I have the chart here, I could circle it. D represent disagree. So that will be here. Okay, this is like the disagree. And C stand for Catholic. So I'm gonna circle it. Did you see, do they have the intersection here? They do, right? You could see they duplicate the 94 in here. We do have an intersection. Means this is not mutually exclusive. Okay, not mutually exclusive. If this is a not mutually exclusive, I'll be using the addition formula. That will be the subtraction with D and C here. Now we're gonna use the formula one by one. First, what is the probability of the disagree? Probability of disagree, which is gonna be 507 over 1,287. What is the probability of C? Okay, probability of C, which is gonna be 301 over 1,287. Okay, D and C. Okay, D and C. When you guys circle it, you're gonna see this is the one who duplicate. So we're gonna subtract one of them. So minus 94 over 1,287. Use the calculator. You should get 714 over 1,287, which is gonna be 0.555. Hey, on the exam, I need you guys show me the notation, okay, what you're looking for. Show me the formula, okay, show me all this work and your final answer. For the chapter test and also the final, I need to see all the work. Here, formula, what did you guys pocket in? What is your final answer? Okay, same idea with this one. You don't have to write this formula, but I need to see this. Okay, probability C, what you are looking for, equal to show me your work and what is the final answer. I'm gonna specify how many decimal space I'm looking for on each question. Last one, use J to stand for jurors and O to stand for other. So I want to find probability J or O, okay? This is or again. So you need to think about it if these two events are mutually exclusive or not mutually exclusive. So when we have the chart here, we're going to circle it. Jurors is going to be here. Other is going to be here. Do they have an intersection or disjoint? They don't have any intersection, right? This is a disjoint. So you know this is going to be mutually exclusive event, okay? Mutually exclusive event. So when we apply the addition, we just need to add up these two. So first, what is the probability for the jurors? That would be 15 over the total outcome plus the other 128 over here. You should get 143 over 1,287. Use the decimal, should be 0.111. Probabilities is always between 0 and 1, okay? So your final answer should be the number in between 0 and 1. If you find something greater than 1, means you make a mistake. That's it for the session 5.2.